NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we will solve equations of the form a times floor of x times floor of y equals k by breaking into clear cases. We will build strong intuition and a visual feel for the solutions. Here is our general equation. We will reference it throughout the video. Case 1. If k is not equal to 0 and it equals 0, then the left side is always 0, but the right side is non-zero. That is a contradiction, so there is no solution. Case 2. If k equals 0 and it equals 0, then the left side is 0 for all x and y. That makes 0 equals 0, an identity. So there are infinitely many solutions. Any real x and any real y work. Case 3. If k is not equal to 0 and a is not equal to 0, divide both sides by a to isolate the floors. We get floor of x times floor of y equals k over a. Since both floors are integers, their product must be an integer. Therefore, k over a must be an integer. If k over a is not an integer, there are no solutions. If it is an integer, there are solutions. Let us visualize case 3 with a concrete example. Suppose it equals 6 and k equals 18. Then k over a equals 3, which is an integer. The equation becomes floor of x times floor of y equals 3. The integer factor pairs of 3 are 1 and 3, 3 and 1, -1 and -3, and -3 and -1. Each factor pair corresponds to a 1 by 1 square of solutions on the plane, because floor of x and floor of y fix x into an interval and y into an interval. To stress the integrality condition, consider a equals 6 and k equals 20. Then k over a equals 10 over 3, which is not an integer. There can be no integer pair of floor of x and floor of y, with product 10 over 3. Therefore, there are no solutions in that case. Let us summarize the complete algorithm. 1. If it equals 0 and k is not 0, there is no solution. 2. If it equals 0 and k equals 0, the identity holds, and there are infinitely many solutions. 3. If it is not 0 and k is not 0, require k over a to be an integer. If it is not an integer, no solution. If it is an integer, there are solutions determined by integer factor pairs, and they're 1 by 1 rectangles on the plane. Final takeaway. Reduce to floor of x times floor of y equals k over a. If and only if k over a is an integer, solutions exist corresponding to all integer factor pairs of that integer, each giving a rectangle of solutions where floor of x and floor of y are fixed. In this lesson, we will solve the equation 3 times the floor of x times the floor of y equals 36. We will go step by step and visualize the factor pairs and the corresponding intervals from the floor definition. First, here is our example and the problem statement on screen. Step 1. Simplify the equation. We use the division property to divide both sides by 3. That gives us the product of the floors equals 12. We can equivalently express one floor in terms of the other as 12 divided by the opposite floor. Step 2. Identify integer divisors. If the product of two integers is 12, both must be divisors of 12. The set of divisors including negatives is plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. Here are the positive factor pairs that multiply to 12, and here are the negative factor pairs that multiply to 12. Step 3. Convert factor pairs into intervals for x and y using the definition of the floor function. The floor of z equals k if and only if k is less than or equal to z and z is less than k plus 1. For example, if the floor of x equals 1 and the floor of y equals 12, then x is between 1 and 2 and y is between 12 and 13. For a negative example, if the floor of x equals -3 and the floor of y equals -4, then x is between -3 and -2 and y is between -4 and -3. In general, for each factor pair k and l in our list, the solution includes all x and y such that x is between k and k plus 1 and y is between l and l plus 1. Finally, here is the complete solution set, all real pairs x, and y such that the pair of floors is one of the following factor pairs of 12. Equivalently, the union of the corresponding rectangles, where x is in the closed open interval k to k plus 1, and y is in the closed open interval L to L plus 1 for every pair k and L listed. In this example, we will solve the equation 3 times floor of x times floor of y equals 35, and we will follow a clean, logical structure to decide whether solutions exist. Step 1. Isolate the product. To isolate, divide both sides by 3. That gives floor of x times floor of y equals 35 divided by 3. And numerically, 35 divided by 3 is about 11.6 repeating. Quick challenge. Think ahead for a moment. Can the product of two integers ever give a non-integer? Write down your thought, and then compare with our next step. Step 2. Use the floor function property. By definition, floor of x and floor of y are integers. The product of two integers is always an integer, but 35 divided by 3 is not an integer, so the equation cannot be satisfied. Step 3. Conclusion. Since the left side is the product of two integers, it must be an integer. The right side is not an integer. Therefore, there are no values of x and y that satisfy the equation. Recap. We isolated the product to floor of x times floor of y equals 35 over 3. We used the fact that floors are integers and the product of integers is an integer. Because 35 over 3 is not an integer, the equation has no solution. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.